Hello class, let's start this with a few fun facts. The first one is about how much is a mole of eggs? How hard is it to get? Now let me tell you this, if someone asks you to get a mole of eggs, that would be a really tough assignment. Now in order to get a mole of eggs, you would need 10 billion chickens, and each chicken would have to lay about 16 eggs per day for about 10.5 billion years. There you have it. That's how you get a mole of eggs. That's a huge, huge number. A mole of hair. And now this is a kind of a hairy situation, but let's take a look at this. If you were to take a mole of a black man's hair, now why black man? Well, because black man, white man, Asian man, we all have the hair thickness is always different. So I know black hair more than any other type of hair. So a black man's hair, if you were to take a mole of that and you put them side by side, not lengthwise, but side by side, so you put the strings side by side, you would go into space 480 million times the distance from the Earth to the Sun. Now talk about a huge number. Okay, now back to more serious stuff. How do we get a number of particles from a number of moles? It's a pretty easy if you know what is the number of moles. If you know the number of moles, then you should be able to get the number of particles easily. All you do is multiply the number of moles by Avogadro's number, because every mole has an Avogadro's number of particles. Let's take an analogy. How many roses are there in 2 dozens? If your answer is 36, then that's wrong. But if you said 24, ta-da, that's correct. How many atoms are there in 2 moles? Well, this is, if you look at these questions, hopefully you can see the similarities. Atoms, roses, dozens, moles. So if you wanted to get the number of moles per atoms, the number of atoms per mole, sorry, then it is similar to trying to get the number of roses per dozens. So if you know 1 dozen is 12, so the number of roses in 2 dozens is 2 times 12. And the number of atoms in 2 moles is the number of atoms in 1 mole, which is 6.02 times 10 to the power of 23 times the number of moles. All right? Let's illustrate this with examples. But before we do that, let's take a look at the formula. The formula of number of particles is NP equals N, number of moles, times capital N or curly N, which is Avogadro's number. So these are the here is an explanation of what those variables represent. Okay, so if you were asked how many dozens are there in 84 roses, I hope you would just go and say 84 divided by 12, and you should get yourself 7 dozens. This is how you do it. All right. So let's see if you understood this. How many atoms are there in 1.56 moles? So go ahead and try that. When you're done, go ahead and try this one. All right, and we'll discuss this in class. So this was it about the number of moles and number of particles. Now we need to talk a little bit about mass on the mole. You should know that the mass of 1 mole is called the molar mass. So the discussion on this slide is going to focus on molar mass. Now here's a trivia question. Which has more representative particles, a mole of hydrogen atoms or a mole of lead atoms? So I'm going to let you think about this, write the answer down, and tell me the answer in class tomorrow when we meet. Here's another question. What is heavier, a mole of hydrogen or a mole of lead? So again, think about this, write down the answer, and let's discuss this in class. Now, as we said earlier, the mass of a mole is called the molar mass. The unit is in grams per mole, or kilograms per mole, or any unit of mass per mole. Don't forget the per mole part. Now, you can find the molar mass easily from the periodic table, because the molar mass is simply equal to the atomic mass of an element. Now, the units are different, because again, we said molar mass has a unit of grams per mole. Okay? For example, if you consider gold, its atomic mass is 196.967 atomic mass units. What is the molar mass of gold? Well, it's 196.967, but what is the unit? Grams per mole. Okay, grams per mole. Now, do you know how to convert grams per mole to, do you know how to convert grams to AMUs? So grams to atomic mass units. If you don't know, Google it or ask me in class when we meet. All right. So now we know how to determine the molar mass of an element. Now the question is, what about a compound? It's pretty easy. You just add up the atomic masses or the molar masses of all the elements that make it. For example, for H2O, it will be 1 plus 1 plus 16 equals 18. And by the way, we have already done this in class, so I'm going to fly over the rest of this. For CaNO3 twice, it's going to be those numbers all added up and multiplied by 2 where necessary, and we get 164 grams per mole. You may round the atomic mass to a whole number if it's very close to being a whole number. Now, how close is very close? We can discuss that in class. Just make sure to ask. Learning check. Please try at least 3 or 4 of these, and then the rest of them we will do in class. So here is a question. If 1 mole of H2O has 18 grams, what would be the mass of 5 moles? I think you could do this easily, even in your head. So there you have it, 90 grams. 90 grams would be the mass of 5 moles of water. What would be the mass of half mole of H2O? Think about it. I'll give you 5 seconds. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. Time is up. You should get 0.5 times 18, 9 grams. Now, if we take into consideration these 2 examples, can we come up with a formula? Yes. Here it is. Mass is equal to number of moles times molar mass. So now you have these 2 formulas that you need to remember. So this one, mass equals number of moles times molar mass, and the previous one, which is number of particles equals number of moles times Avogadro's number. Keep these 2 equations in mind. We will be using them all the time. Okay? So here is a question. Do you think you can handle it? Go for it. Go for it. Challenge number 1, give it a try. However, challenge number 2, we will just have to do it in class. Okay? Maybe even challenge number 1, we will have to do them in class. But give them a try. Give the first 2 questions and challenge 1 a try, and then we'll see. Okay? So moving on, we are already at 7 minutes 45 seconds. So we have about a minute to go. So we already know mass, molar mass, and number of particles. So this slide kind of gives us an overview. So we can convert mass to number of particles, not. Okay, we can convert this not. We cannot go straight from mass to number of particles. We must stop by number of moles. Okay, you always have to go by the number of moles. From mass to number of particles, or from number of particles to mass, you have to use the number of moles. Okay, and here are the equations that allow us to do these conversions. Here is a visual. Okay, again from mass. Can you see it? I don't see my pointer. Hope you can see it. So on the left we have mass. In order to go from mass to number of moles, we have to stop by the number of moles. Okay. Learning check. So you do these 2, and then you just do these 2, and then the rest of them we will do in class. Okay? This is the end of this video. See you in class. Thank you.